In this first chapter, you will be learning about deformers, which are nodes used to manipulate 3D geometry. Deformers are incredibly powerful tools to sculpt and change 3D objects and meshes without the need of tedious keyframing. And you can control deformers with modifiers, which we talked about in the Notch Essential course. This chapter features multiple workshops where I'm asking you to load up the correct project from the asset pack and follow along with the video to repeat what I'm doing and learn for yourself. You're free to pause or rewind the video if you need to, there is no rush. Welcome to Notch Intermediate course. In this chapter we will talk about deformers. Now in this setup we have several layers already available for us. So we have Simple Deformer Start and Simple Deformers Finish. So this is pretty much where we are heading in the upcoming workshop. We will be building all of these setups one by one until we have all of those accomplished. So let's get started. I'm going to open the Simple Deformer Start. And first of all, I'm going to walk you through the node that we have here in the node graph. So here on the left-hand side, we have a little bit of a lighting fixture. So we're using skylight with environment map. And we have a fog scattering for the background. Here in the bottom, we have a floor arrangement. So it's a shape 3D with a material and a grid generator. And if we scroll a little bit higher, we will see that we have 5 arrangements right here that we will alter as we progress through the workshops. So we have a text node stating the number of the arrangement. And we have a null that childs to shape 3Ds. Now the top shape 3D only shows us the point arrangement. And the bottom one is exactly where we're going to put deformers, exactly what we're going to work with. So with this mentioned, I think this is a very good time for us to add a first deformer to the scene. So I'm going to head over to the node list, and if I expand the deformer list, I see that there's quite a few of them to choose from. Now, I would say that there are some that could be defined as simple deformers and some as more complex ones. When I say simple deformer, I'm referring to a deformer that doesn't require extra information, so it literally works out of the box. So one of these out-of-the-box deformers would definitely be a turbulence. I'm going to scroll through and find the turbulence deformer. So here it is. I have it in the graph now. I'm going to zoom in a little bit closer. So the way all deformers work, they are connected to the shape 3D or 3D object that you actually want to deform or change the appearance of. So in this case, as mentioned, I'm going to work with the bottom arrangements here. So I'm going to grab this shape 3D and I'm going to connect turbulence to the shape 3D. There we go. I already see that there's something happening, and if I start the playhead, I see that it's turbulating. Great. I do have a displacement amount property, so I'm going to increase that so we see the effect a little bit better. And here we are. We are turbulating this shape 3D with a deformer. We're not obliged to use one deformer just for one shape. We can actually use the same deformer on quite a few of them. In fact, I'm going to connect the same turbulence deformer to the second setup right here. So to this shape 3D. Now notice that there's a bit of a difference in appearance of the first one and the second one. I think I'm going to increase the displacement amount here for a better visibility. So let's say if we stop the playhead now, you will see that the first shape 3D is much smoother than the second one. Why exactly is that happening? Well, we have more subdivisions in the first one than in the second one. As you notice, the step right here is much more dense than in the second one. You can define how dense the shape should be in the shape 3D properties under the subdivision X and Y. So the default is 20 by 20. That's exactly what we have here. And in the first one, I already increased it to 70 by 70. So that's why they look quite different and they wrap quite differently. All right, let's get back to the very node and let's talk about its properties. I think I'm going to unhook this turbulence from this shape 3D. And I'm going to talk about properties inside the very node. So we have positional values, and then we have properties that are alterable and specific to a deformer. In this case, the turbulence has a displacement amount, max displacement, noise scale, gain, and so on and so forth, even animation rate. In fact, we can slow down the animation rate quite a bit. So 0.2 on this value right here. And let's set this displacement amount to 0.5 so we have a little bit more flash numbers. Now, I want to draw your attention to the last bracket here, fall off. So if I enable fall off, all of a sudden, there is this sphere around the shape. So this sphere right here is our area of influence. So let's see if we make this fall off range quite smaller. I'm going to go for 2, for instance. Now I'm gonna hit 0 to come back to the active rendering camera. In fact, I'm gonna make it even smaller still. So maybe something like 0.7. And I'm gonna increase the fall of inner range too. So that step, this influence would become more visible rapidly. So there we go, something like 0.5 here. Now notice if I start to change the positional values of this deformer, it only affects the shape 3D where the fall of hits it. So I'm literally changing the position Y. And now we're applying this deformer only where the sphere of influence is actually hitting it. So the fall off is the sphere of influence. Maybe it's not the most technical term to describe it, but it kind of helps me to understand what does it do and how does it work. Okay, let's add one more deformer to this setup, because we're not bound to just one deformer per one shape 3D. I think the extra one that I want to apply here would be a twist deformer. So I'm going to grab twist deformer and I'm going to connect to the very same shape 3D. I think I'm going to increase the displacement amount a little bit and I'm going to offset some positional values. There we go. So maybe something like this. Now I'm generally improvising on these numbers. I'm going to flush them out as soon as we enable the fall off. And we're going to go through the same procedure of making the fall off smaller and maybe the inner fall off range a little bit bigger, and we position it, let's say, in the bottom. So first of all, I'm going to enable it. Now, if I pan out to the orb view, I see that fall off is active. That's great. I'm going to come back to the active rendering camera and I'm going to make this fall off smaller and with the bigger inner range. Smaller still. There we go. Something like that. And I want this twist deformer to apply on the shape, let's say only from the top, so even smaller still. I think our inner range was a little bit too big now. Yeah, I think this works. So here we are, we're applying this twister only on the top. Let's give it even more displacement amount. There we go. So turbulence is here in the bottom and our twist is here at the very top. Let's see if we can offset it so it's a little bit more visible. Ah, there we go. Now it's a bit more crazy and a bit more interesting. Right, so we have two deformers applied on the same shape 3D and you can see how abstract this sphere, this shape 3D is becoming. Now back to the twist deformer, let's just flesh out these numbers so it's a little bit more clear for you guys. What values did we set in? So I think this could easily be a 0. This could be 0.5 on the position Y. Position Z could be 0.3. Rotation heading, let's give it 65. Okay, great. Displacement amount, we can flesh it up to 2. And let's see, fall off range, that could be just 1, for instance, and 0.5 on the inner range. If you're ever wondering what properties are changed from the default values, you will notice that the values that have been altered, they are marked up a little bit brighter than the rest. So if you're ever in doubt on what was offset from the default values, just don't forget to check out the color palettes here. So a little bit brighter if it's actually altered. Right, even though we have quite a bit of subdivisions here in the shape 3D, I think it's still a little bit crude, this step right here. So I could do two things. I could either go and increase the subdivisions on X and Y, or I could add an extra deformer here to make this a little bit smoother. The deformer that would help us here, it's called exactly that, smoothing deformer. So I'm going to connect it to the shape 3D. And as you see, as soon as I connect it, all of a sudden, it already looks a little bit smoother. And if I increase the smooth iterations, you will see that it's smoother still. I will not bother you with the technical description of a smoothing deformer, but in many respects, this deformer is just smooths out the edges of the available geometry. Now, important thing to mention and to notice, if you change the position, stacking order of the deformers, they change their look. So just like with the post effects, just like with the video processing, the stacking order is very important. So Notch reads all the nodes from top to bottom, or from left to right if it doesn't recognize a stacking order from top to bottom. So this is just a little thing to remember. Okay, I'm gonna hit 0. And I think I'm going to round this setting up with one more deformer, a little bit more interesting one, and that deformer is called Slice. I'm going to grab a Slice deformer. I'm going to apply it as the very last thing in this chain. So from top to bottom, there's twist, turbulence, smoothing, and then slice. Slice does exactly what the name implies. It literally slices the geometry. I think I want this to be rotated a little bit. So maybe I will change the value of the pitch, for instance. So minus 45 here. I think the slice thickness could be bigger, but scale, yeah, scale could be bigger too. Let's just have more. More is more. Okay, this is rather interesting and nice looking. I think I'm going to leave it at that. Again, subdivisions are very important. So if I was to apply all of these deformers to this shape 3D, you will notice that the look is a little bit different. We have 20 by 20 subdivisions here, and we have 70 by 70 subdivisions here. Right, so while we're on the topic of subdivisions and points, notice that this third arrangement right here looks a little bit different than the first and the second. And that is because in the third sphere, the points are distributed a little bit different. So it's distributed as triangles and not like a quads like in the first and the second setup. So we could easily grab the very same deformers and apply it here on the shape 3D, or in this case, imported sphere object. And you will see that they look and behave very different. And that is because the points are distributed quite differently. So I will unhook these deformers, and I'm going to apply some other deformers here on this setup. But before I move on to any creative settings in this arrangement, I think I'm going to explain you why does this sphere look very different from, let's say, these two. So this sphere right here is not a primitive that we have here in Notch. I imported this sphere from Cinema 4D. In this case, if in Cinema 4D I choose a sphere as a primitive, I'm just going to make sure that we have ground shading and lines available too. This is arranged as quads, or in this case they're calling it standard, but you can actually choose some other arrangements. So I think what I've chosen here is icosahedron. That is not an easy word to pronounce. Right, so I just chose this type of arrangement and I saved it up, and then I opened it in Notch. And that's exactly why we have triangles here and we have quads here. So with that said, I think we can apply some kind of a deformer. I'm going to go for Displacement Deformer. Right, so this is the shape that I want to use, and I'm going to connect it up. Let's increase the displacement amount. I see it is working. If I scroll a little bit lower, I see that there's animation rate property. I think I'm going to increase that. There we go. Now we see it animating. That's great. I don't think I need much of noise amount, so I'm going to just take that out and I'm going to increase the displacement amount. Now, how about more fractal noise here? Maybe 5. There we go. This is much more interesting. This is already quite fun. I think I'm quite happy with this. Perhaps the only thing that I would change, I would add some fractal noise threshold. So those spikes do not cover the whole mesh, but it covers only the specific spot. So maybe 0.2 on that setting right here. Great. So we covered the subdivisions in primitives. And we have that as an option under the very node. There's attributes and there's subdivisions X and Y. So how do we subdivide an imported 3D model? Well, in the imported 3D model, we have a property called subdivision level. So in this case, it's set to 0. If I bump it up to, say, 1, you already see that there's a little bit of a difference on the model compared to the top one. We can bump it up further and further, but I think I'm going to stay with 1. So we have increased the subdivisions, but it didn't change the way the displacement deformer is applied on the 3D model. And that is because we didn't change subdivision order property in the very deformer. So in this case, I'm going to go for subdivision order after subdivisions. So all of a sudden, this deformer is accounting for the subdivision level that we set in. Now, mind you, be cautious about the numbers we are using in the subdivisions because you're literally adding more points to the 3D object, thus increasing the computational load on the system. Right, I think we're ready to move on to the fourth setup. So in this setup right here, we will chain up several deformers, and one of them will be a little bit more complex than the ones that we've tried out so far. But let's start simple. We're gonna grab the shape 3D and we're gonna apply 3D Plasma Deformer on it. There we go. Maybe let's increase the spikes to 15 by 15 by 15. There we go. It is working. Should we add a bit more animation rate so we see that it's moving? Yep, it's working. Great. So the next deformer that we will apply here is called Weight Map Deformer. So if so far we were able to control the area of influence via fall off, we can actually control area of influence with a external image or a generator image. And we can do that by applying weight map. So I'm going to grab that node right now. There it is, generate weight map deformer. Now, mind you, again, the stacking order is rather important here. So first we will want to generate the weight map, and then we will want to apply some creative deformer. In this case, we have 3D plasma. Okay, so let's make some alterations in the weight map deformer node. It doesn't really work or do much when it's set to default. So first of all, I'm going to grab a image or a picture that I want to use as a weight map. I could import something from Photoshop or from my personal resources, but I think I'm going to go for a generator. In this case, Truchette. So I'm going to grab that, pipe it into the node graph, and I see that the first input right here is image. So I'm going to connect it exactly there. Now, before we go to a specifics of a generate weight map node, I'm going to make some alterations in the Truchette. By default, it's set to a rounded mode. I don't necessarily want that. I think I'm going to set it to a linear. I kind of enjoyed this a little bit more. For now, it's probably the only change that I want to do. So I'm going to untick the preview in the viewport. And I'm going to come back to the generate weight map. Now, I see I have an option called mode. So in this case, I want this to work with the texture as we just built one via Truchette. So I'm going to hit texture. And if I scroll a little bit lower, I see that there's a property called show weight map. That's quite important for me to see. So I really want to see how does this Truchette wrap around the 3D object. So in this case, I'm just going to tick on show weight map. Great. So with the mode changed and show weight map ticked on, I think I can make sure that this generated weight map works together with this 3D Plasma Deformer. If I hover over the inputs here in the 3D Plasma Deformer, I will see that there is an input for generated weight map. Majority of deformers, I'd say 95% of them has this input, generated weight map. That's exactly where we can pipe in our newly made generate weight map deformer. And as we connect it, I see that this 3D plasma is wrapping around the shape 3D in a shape that generate weight map deformer is implying. So if I start playback, it's definitely working. It's definitely deforming the model. There's a couple of things that I would like to do here more. For instance, I'm not necessarily happy with the way it's tearing the model. So to address that, there are several things we can do. First of all, we obviously could increase the subdivisions, but they're already quite high. So it's 70 by 70. Another thing we could do, we could go back to our Truchette and make sure that this Truchette is a little bit smoother. As you see now, the edges are really sharp. But if we add something like blur and bump it up quite high, for instance, 50, all of a sudden these edges are quite smoother. I think I overdid it actually. Maybe 50 is a bit too much. I think we're quite happy with the 15. There we go. This looks much better already. We still have a little bit of a jitter edge, so we can apply the very same deformer that we already tried before, and that is smoothing deformer. That should probably flesh out our setting quite a lot. Right, I'm going to increase the smooth iterations to 5. This looks way better now. I'm quite happy here. In fact, I'm going to go back to my 3D plasma and I'm going to increase the displacement amount to something bigger, like 0.15. So to top this off or to push it a little bit further, we can actually animate our texture. In this case, if we preview it in a viewport, perhaps we want this Truchette to scroll on the position Y value. So here I could use something like continuous modifier, piped into position Y setting. And there we are. It is scrolling. It is scrolling a little bit too fast for my liking. So I'm going to decrease the speed to 0.1. So with that done, I'm going to tick off preview in the viewport. And the texture is then animating the generated weight map deformer which is then piped to the 3D plasma, and all of these things are all of a sudden working together. Great! I think this captures the essence of the Generate Weight Map Deformer. We're gonna come back to this time and time again because it's really handy node right there. Cool, let's move on to the last setup, to number 5. So here we're gonna grab a deformer that we are already familiar with, a slice deformer, and we're gonna apply it to the shape 3D. There we go. I think we could afford a little smaller thickness and a little bit more of these slices. So I'd say maybe, well, let's flesh it. So 10 slices, and the thickness could be 0.25. Let's pivot it so we see them better. There we go. We just changed the rotation pitch value. I'd say -45 probably would be good. So let's add one more node here. Let's add one more deformer to this setting. Let's add a Chunk Effector Deformer. I'm gonna connect it below the slice deformer because first we want to slice and then we want to chunk. Now, Chunk Effector Deformer doesn't do much, just like a Generated Weight Map Deformer. It requires extra information. So if I hover over the inputs here, I will see that I can use the Generated Weight Map, but that's not really what we're going after. I'm gonna go for Effectors instead. If I go to my node list and I open up the cloning tab, I will see that I have a whole list of effectors. So Chunk Effector Deformer takes advantage of cloners, effectors. I'm gonna grab something simple for now. I think turbulence will be perfect here. So I'm gonna connect turbulence to the first input here. And I'm gonna make sure to offset some values in the effector transform. And as I offset those values, I already see that it's affecting the way that slices are arranged on the shape 3D. So not only we are slicing the model, we're actually making geometry out of this shape 3D. All of a sudden we have these slices as separate pieces of geometry, so to say. So before we go any further, I think I'm going to walk you through the basic settings of this turbulence effector. All the effectors has a transform tab, which is responsible for the 3D positional values of the effector. Then we have attributes, and attributes are responsible for specific animations that are available to that effector. In this case, I think I'm going to just drop down the animation rate. Then we have a fall off. We are already familiar with the fall off. And effector transform. So effector transform is responsible for the animations of that specific effector. So if the top bracket transform is responsible for the 3D positionals, the bottom one is responsible for its behavior. What does exactly this effector do? Now I'm not going to talk further about different available options here because we will come back to effectors quite in depth when we're going to talk about cloners. But before we move on to cloners, I think it's going to be very interesting to talk about Chunk Effector Deformer a little bit further. So in this case, we're applying the Chunk Effector Deformer on a proprietary shape 3D. But what if you have another 3D object that you brought in from another package and you, for instance, want to shatter it? Well, that's exactly the next workshop that we're going to be working on, Chunk Deformer with the external 3D object. So see you in a moment. Welcome back to Notch Intermediate course. Let's talk about Chunk Effector Deformer a little bit more. In this case, we will be looking at the Chunk Effector Deformer while it's using an external 3D file. So let me walk you through the nodes that we have in the initial setup, the third layer Chunk Deformer Start. We have the very same lighting system as we had in a previous setting. So we have fog scattering, skylight, we have a camera looking to this setting, and here in the bottom we have a shape 3D with the grid generator for the floor. And here on the very side, we have a 3D object that we brought in from another package that we're going to now use with the Chunk Effector Deformer. Now, before we get started with the Chunk Effector Deformer, I see that there's a little issue with this model. All the chunks has smoothing enabled, and I don't think we need that. It actually makes it look really broken. So I'm going to start by adding a material. I'm going to connect it to the material input here. And I'm going to find smoothing property. So normal smoothness, I'm going to set it to 0. There we go. This is much better indeed. I think now we are ready to add a Chunk Effector Deformer. So let's do that. First thing that we're going to change, or actually the only thing that we're going to change inside of the very node, is the vertex source mode. So instead of vertex positions, we're going to go for chunks, because we want notch to refer to available chunks. So how do we progress further? Well, again, we need some kind of a effector. In this case, we have quite a few to choose from. I think we can start with something rather simple. So I'm going to go for plain effector. And I'm going to connect it to the first input. There it is, it's all set up. It doesn't have any transforms just yet, so I'm going to take care of that. First of all, I'm going to take on uniform scale, and I'm going to use this scale X slider to make all the chunks smaller. So all of a sudden, we are taking advantage of all the little chunks that this model had. Let's add a couple more effectors. I think I'm going to go for turbulence effector here. Perhaps the plane effector could have a bigger impact, so I'm just going to make everything a little bit smaller. There we go. Maybe -1. Now I'm going to connect a turbulence effector to the very same input. There we go. And I'm going to do the same operation. Uniform scale, take that on, and I'm going to make sure that things are getting a little bit bigger. If I start playhead, now I see that these chunks are turbulating. That's great. It's a little bit too fast. Maybe it could be slower. So animation rate, I'm going to reduce that something like 0.2, for instance. Perhaps they could be turning in some way as well. So I'm going to change the rotation heading. I'm going to change the pitch and banking. There, it's a little bit more interesting now. Now, you probably already noticed that we have a fall off. We have already spoken about it in a previous chapter. But let's take advantage of fall off in this effector. I'm going to scroll and find the fall off bracket, and there we are. And I'm going to make this fall off quite smaller. Perhaps 4 would work here. Right, so next thing I could do, I could probably lift it up so it actually hits the model. And now I could use something like a math modifier to drive it left and right. I think I'm going to do that. First of all, I'm going to make sure that the position X is set to 0. And I'm going to grab a math modifier. Let's connect it to the position X value. There we go. I see it's working. It's a little bit too small, so maybe we can give it a bit more scale, maybe 8. And it could be rather slower. So 8 on a scale and 0.1 on speed. There it is, going in and going out. Great. I think we could make the plane effector a little bit bigger on a scale X property. There we are, it's working. Well, let's add one more effector. Perhaps a randomize effector would work great for us here. So I'm going to grab that randomize effector. I'm going to connect it to the first input in that Chunk Effector Deformer. And on the randomize effector, I'm going to tick on uniform scale again. I'm going to decrease the scale to 0.5 or -0.5. And I'm going to change the pitch heading and rotation. In fact, I think I want the same settings for fall off on this randomize effector, just like I have on the turbulence effector. So in the turbulence effector, I'm going to head to the fall off bracket. I'm going to press on the top of the bracket, press Ctrl C, and I'm going to be back to the randomize effector, press on the fall off bracket, and I'm going to press Ctrl V. So now I copied out the fall off properties from turbulence to randomize effector. Now, turbulence effector is a little bit higher, and a randomize effector is still in the 0 spot. So I could probably match these numbers, so I would have to relocate the randomize effector to the position by 3.5 position, or I can go a little bit smarter than that. So instead of resetting the positional values of every single added effector, I could bring them all back to the 0 state. So I'm going to put 0 here. I'm going to disable this math modifier for now. Yeah, so my turbulence is on 0 and my randomized effector is on 0. And instead of controlling these things separately, I could use a null to control them both at the same time. So in this case, I'm grabbing a geometry null. I'm going to connect it to the root. And you may have noticed that Effectors has a parenting handle available, but they're not parented and still working. So the reason why they have the parenting handle is because we can use a null or a 3D object to drive their positional values. In fact, we can chain up several of them, and all of them will be controlled by that specific null or 3D object. There we go. So I'm just gonna double check that randomize effector is in the 0 state. It is. Turbulence effector as well. That's great. So now with this null, I can change the positional values of both of the turbulence and randomize effector. So this is a great way to build more complex control or to unify several effectors to make more interesting, more complex animations. Now, I think there's one thing we're lacking here. It's very hard to see where those fall-offs exist. I think we can address that. If we were to make a little image plane with, let's say, a image file that just has a little ring, that would actually help us to see where the fall-offs are actually working. Lucky for us, I have one little resource available here in the resource tab. It's a PNG with a see-through ring. I think we're gonna take advantage of that. So we're gonna grab a image plane. We will connect it to the very same null because we want this image plane to travel together with the null. Let's just maybe make it a little bit bigger. There we go. So this is our quad image plane, and let's pipe in the video loader to the first input. Now we have that ring, and it follows the position of null, and null drives the position now of the turbulence, the randomize effector, and the very image plane. Let's see that the sizes match up more or less. So turbulence, yeah, it's a little bit bigger, so it's randomize effector. So let's make this image plane bigger as well. There we go. Yep, this is quite closer. So instead of offsetting the position X of every single of these operators, I can apply the position X offset straight on the null, and I will be able to control them all at once. Of course, I should probably zero this out before I go anywhere further. I think this would be a little bit more visually appealing if this image plane would be in black and white. So I'm going to go for color correction. I'm going to connect it to the video loader, and I'm going to decrease the saturation. In fact, in an image plane, I could easily drop the alpha a little bit. There we go, so something like 0.5. Perfect, so to push this further still, I could probably change the blend function to add. It's just gonna look a little bit nicer. And I think I would like to have this ring banking, so it looks like it's turning round and round and round. So I can use a continuous modifier there. Let's see, there's bank. I'm gonna put it to 0 state again. Let's connect it, and let's just double check our animations. I think it's rather slow. Let's speed it up. Let's add 10 to that value. Or actually even 30, let's just be generous. There we go, it is working. Now, there's one little thing that you may have noticed. As I'm approaching the end of the timeline that is available, when I'm hitting the 30-second mark, all of a sudden, this setting jumps. So there's a good reason for that. In a math modifier, we can change the time mode from locked to timecode to a use deltas. And we can do the same thing to any and all effectors that has some kind of animation. So for instance, turbulence. Update time mode, instead of locked to timecode, let's go for running loopable. Now, once we're gonna hit the 30-second mark, you will see that it's still going smooth and there's no changes towards how it's working with the time. Great, so now we know how to use the effectors with the null as a controller. Well, can we use some other deformers with this type of control? Well, in fact, we can. So if we were to grab any and all deformer, let's just add turbulence, for instance. Let's make sure that it's quite visible. Yeah, this is quite strong. We can connect this turbulence to the null, but we don't have an option to parent it via the parenting handle because it's being used by the very 3D object we are deforming. But if you hover over the input in the bottom, you will see that there are several options. The second one is fall off node. So if we had a fall off enabled on the turbulence, let's do that. Yep, I see it came in, it's rather big. I'm gonna make it quite smaller. There we are. I'm gonna make the inner range a little bit bigger. Now we can attach null to this fall of control input. So let's do that. And as we do, I see that it's already working and working together with the rest of the setting. Perhaps it could be bigger, as attaching it to the input actually changed the size property a little bit. There we are. So with one handle, with one null, we're controlling the Chunk Effector deformer that has several effectors attached to it. We're controlling the image plane. And we're controlling an extra deformer, which in this case is turbulence deformer. So before we move on further, let's talk a little bit about the very model that we have here and how it was prepared. I am a Cinema 4D user, so I prepared my file in Cinema 4D. If you're using any other 3D package, I'm sure that the package that you're using has similar tools to fulfill the task that I'm about to show. So I'm going to grab a primitive that is available in Cinema 4D, so in this case a platonic, and I'm going to go for MoGraph Fracture Voronoi. So if I put this platonic under the Fracture Voronoi now, I see that I have these shatter shapes. Now if I head to Fracture Voronoi, I can make further tweaks and alterations towards how does this setup look by adding more or less points, shattering to bigger or smaller pieces, so on and so forward. But for me to be able to take advantage of this setting in Notch, all I have to do is to make sure that this setting right here is an actual geometry. So if I right click now and go for make editable, now I have all of these chunks, all of these pieces as geometry. And that's great. But before I move on and bring it into Notch, I have to make sure that all of these pieces are actually connected to one solid object. So I'm going to mark everything up and I'm going to choose an option called Connect Objects and Delete. Now we do have one object, but all the shattered pieces are still contained in that one object. And that's great. That's exactly what we needed. So now I have two options. Either I just save it up as a Cinema 4D file because Notch reads Cinema 4D files natively, or I would have to export it as a OBJ. For instance, if you're working with another package, maybe FBX or OBJ would be a better choice. So if you're exporting an OBJ file, make sure to tick on Export Duplicate Vertices to be able to take advantage of this workflow. So the file that we're using in this workshop can be found in the assets. So if you just head to Assets, 3D Meshes, you will find this 3D object available for you there. In practical terms, this could be a very interesting workflow for interactive setting. If you have a building mapping and you want your customer to be able to disperse parts and shatter parts, you might as well build an OSC controller and allow him to do that via this Chunk Effector deformer. Or if you're working with a car manufacturer who just created a new car and you want to open up the car and see what's inside under the hood, you might as well use this Verinode setup to allow yourself or other people to disperse the model and see what's inside of it or beneath it. So I'll give you a chance to further explore this setup, perhaps add more deformers, perhaps add more effectors. And whilst you're working on this, I'm going to go and prepare for a next chapter, cloners. And I hope to see you there soon.